In this class 48 of the medium-level refrigeration and air conditioning course, we are going to study the pressures of air conditioning that works with r32 refrigerant gas. Go ahead, Luis, with the explanation.
In recent years, there has been an increase in demand for this type of air conditioning, due to its energy efficiency and low environmental impact. Let's start by saying that r32 is not a replacement gas for R410 in equipment that is working, but should only be used in new equipment, specially designed for this gas. The parts of an air conditioner, which works with r32 refrigerant gas, are the same as a conventional one, so we have in the indoor unit, which is located inside the premises. Evaporator turbine in the outdoor unit, which is located outside the premises. We have compressor, capacitor, condenser fan safe, capillary tube. We also have the pipes that join the outdoor and indoor unit. Liquid line, steam line. The pressures of the refrigerant gas r32 are very similar to those of R410, so we have for an evaporator temperature of 5 degrees C, the manometer of an air conditioner with r32 should read about 129 psi. The high pressure of an air conditioner that works with r32 for an outdoor ambient temperature of 30 degrees Celsius should mark close to 350 psi.
R32 is a pure HFC type refrigerant, with a low global warming potential index, high efficiency and refrigeration power, which has made it the refrigerant of choice for many manufacturers for their new equipment. Now let's study in detail the characteristics of the refrigerant r32. 1. R32 refrigerant is a refrigerant classified as A2L, slightly flammable, more energy efficient than R410 and with a global warming of 675. 2. Refrigerant manufacturers have clearly stated that r32 refrigerant is not suitable for retrofitting. That is, another gas should not be removed from a working piece of equipment and replaced with r32. 3. A system that was originally designed for R410 will not have taken into account the safety factors required when using an A2L refrigerant such as R32 and could create a significant safety hazard. This means that R32 should only be used by manufacturers of new air conditioners. 4. The discharge temperature of the compressor, which works with R32 refrigerant, is high, so the heat recovery option can be used. 5. R32 has better efficiency and around 10% more capacity than R410, depending on the application and system design. 6. The charge amount of R32 refrigerant is about 30% less compared to R410. 7. R32 is a relatively inexpensive single-component refrigerant, which means it is easier to recycle. 8. The fact that there is no patent on R32 ensures access and availability through many refrigerant suppliers, ensuring that R32 remains cheaper than its competitors.
However, this is not all we need to know. There is something very important and not many omit. I'm talking about the discharge temperature that the r32 refrigerant has. Remember that the compressor discharge temperature is the most critical in the refrigeration cycle because it is the highest temperature in the system and must always be within the ranges that the equipment compressor and its lubricating oil emit. This value is higher than the condenser temperature, because the refrigerant r32 is in a superheated vapor state. If a compressor works with higher discharge temperatures than it was designed for, it will quickly fail. Also remember that the viscosity of the oil refers to the resistance that this liquid has to flow or deform. If the temperature increases to inappropriate values, the viscosity decreases. This causes the oil to not stay at the points where it should be to achieve lubrication. Now let's look at the graph. Let's look at the discharge temperature of R400 and compare it with that of R32. We can see that the discharge temperature of R32 in this example exceeds that of R400 by 16 degrees Celsius, and this actually happens very frequently. From this we can conclude that if we update a unit that is working with R400 refrigerant by now adding R32 refrigerant, the compressor will have higher discharge temperatures, which will significantly shorten the useful life of the compressor. In the equipment specially designed for R32 refrigerant, this problem of high discharge temperature is dealt with, either with cooling strategies or with different oil viscosities, so that the compressor does not have problems. Let us remember that one of the reasons why some technicians decide to replace R-400 with R-32 is the lower cost that the latter has. However, this is not justified if in the end the compressor of the equipment is going to be affected. In conclusion, neither for safety nor for the damage that will be caused to the equipment, we must replace the R400 refrigerant with R32 in systems that are already working.
Before we finish, we must answer two typical questions. Question 1. Is R32 refrigerant easy to ignite?
Dos.
R32 refrigerant is actually difficult to ignite, and requires certain conditions to be met. 2. There would have to be a significant coolant leak.
B.
The leakage should be sufficient to reach a lower flammable limit concentration. C. There would have to be an open flame or high-energy ignition source, where the concentration is sufficient to ignite the R32. Question 2. Does the R32 ignite from static sparks? Not really, as R32 must be exposed to an open flame or high-energy source to ignite. Remember, the Institute of Refrigeration and Air Conditioning in the United States is clear in stating that updating or drop-in should not be carried out with refrigerants with flammability classifications other than the original equipment refrigerant.